Welcome back to the Oasis Tutorial Series where we create a Fortnite Island from scratch. In the experience you can sit back and listen to some music while you relax or talk with your friends. My name is Stefan, I'm an Unreal Authorized instructor, and in this video we're going to build some of the visual effects I have used to bring the environment to life and visualize the music on this island. The tutorial is aimed toward intermediate users, so you should have some basic UEFN experience already. If you want to start from the beginning and learn more about the project, feel free to watch the first part of the series. I have it linked in the video description. Please also check out the finished island with the island code or using the link I've provided. We're going to create these random floating 3D shapes as well as the magical streaks that surround the island. We're also going to prepare functionality to be able to animate them to the music later on. After this video you will be able to create your own custom visual effects for your Fortnite islands, explain the building blocks from which these effects are built, create specific materials to be used with your visual effects, and implement ways to animate various parameters of your visual effects. To create custom particle effects in UEFN, you can utilize the Niagara system. Niagara is Unreal Engine's next generation VFX system. Remember that UEFN is also based on the Unreal Engine, like the default Unreal editor. We don't have access to the full functionality in UEFN, but the basics are the same. Niagara makes use of particles and various ways of placing them and making them move. We have a lot of control over how the particles look and what they do. Niagara is built from these building blocks, which are also asset types. The system. The system is a container for your effect. It houses all of the building blocks you need to create it. That is also the thing that you can place in a level. Emitters are the heart of the Niagara system, responsible for generating and controlling particles. They define how particles look, behave, and evolve over their lifetime. Emitters are organized in a structured stack divided into key groups. Emitter settings. These control general properties of the emitter, such as whether it uses the CPU or the GPU. Emitter spawn defines what happens when the emitter is created, setting the foundation for the particle generation. Emitter update manages what happens throughout the emitter's lifetime, including particle creation. Particle spawn controls what happens when the particles are born. This includes initializing settings like their lifetime, color, and shape, as well as where they are created. Particle update determines how particles change over time, controlling movement, color shifts, and other behaviors. Event handler allows emitters to generate and handle events, enabling communication between emitters. Render specifies the type of particles used, whether it's sprites, ribbons, or 3D objects, and defines their appearance. Each group plays a vital role in shaping how particles behave, ensuring dynamic and flexible effects. The next essential building block in the Niagara system is modules. Modules are the foundation of your visual effects, serving as containers for mathematical operations that determine how the particles behave. These modules are processed in order, from top to bottom, shaping everything from particle movement to appearance. Niagara comes with a library of pre-made modules, but you can also create your own using HLSL for complete customization. Then we have parameters, which define the settings of your visual effects. Think of them as editable data storages that control everything from particle size to color to movement. There are various parameter types for different types of data, many of which are built into the system or emitter by default. You can also create custom user parameters to control specific settings externally, making your effects even more dynamic and versatile. When you create a system, you can use one of the templates and adapt it to your needs, or you can start from scratch. So here I am in UEFN, and I first want to create the effect of the random spinning 3D shapes. I'm going to start by creating a new folder to house all of my effects. So new folder, call it effects, and inside of that folder I'm going to create a new Niagara system. Once I do this, it prompts me to start from one of these templates here. I'm going to choose the minimal one because we're going to start basically from scratch. So choose the minimal one and then click on create. Now it prompts me to name this. I'm going to call this NS for Niagara system and then random 3D shapes. Double click to open. Let me first give you a quick overview of the user interface. On the top left here we have a 3D preview of our Niagara system. In the center we have the graph with these building blocks, here the system in blue, and in orange the emitter. There could be multiple emitters, but for now there's only one. Once I select something, for example the emitter, on the right side in the details panel I can see the settings as with any editor in the Unreal editor. On the bottom we have a timeline that we can play and pause and also scrub through to see our Niagara effect in action. As you can see, we only have some very basic modules, the building blocks, in our emitter right now. We only have the emitter state, initialize particle, the particle state, and the sprite renderer, and these are separated into the emitter update, particle spawn, particle update, and render section. First, I want to change how my particles look. Right now, these are so-called sprites, so basically 2D planes that always orient towards the camera of the viewer, and these can have materials with textures on them. But we want 3D shapes, so I'm going to delete the module of the sprite renderer, right-click and delete, or just hit the delete key, and then here on plus in render, I'm going to add a so-called mesh renderer, and this allows me to render 3D meshes. With the mesh renderer selected, in my details panel, I can now assign meshes that should be rendered. So if I expand this, I see I have one default mesh assigned here, and with the plus, I can assign multiple meshes to the same mesh renderer. So I'm going to change this first mesh index here to a cube, if I can write, cube. And then with the plus button, I'm going to add a few more. And I'm going to add a cone, a cylinder, and a sphere. Just the basic 3D shapes. In my original system, I used these musical instruments, like for example this guitar here, but for the purpose of this tutorial, we're going to use the simple 3D shapes. Now we have the 3D shapes set up in our mesh renderer, but we still cannot see any meshes in our 3D preview. To change that, we need to spawn particles. We need to tell the emitter to create the particles. And for that, we're going to use a so-called spawn rate. In the emitter update section, I'm going to click on plus and then click on spawn rate. This adds this module here, and in the details panel, I can set up how many particles per second should be spawned. So if I set up one particle per second will be spawned. And since all of the particles are spawned at the same location currently, we always see the same cube, even though there are multiple cubes. So let's set it up that our cube is not always spawned at the same location. To make sure that we can also see what's happening, we should also start playing the timeline again, so we see the cubes spawning. To set it up that the cube is not spawned at the same location, I'm going to use under particle spawn a so-called shape location. This allows me to define a shape, like a sphere, cylinder, box, torus, ring, or cone, on which the particles are placed when they are spawned, so when they are generated. If I choose sphere here and increase the sphere radius to, let's say, 500, we should see multiple cubes spawning at different locations on top of a sphere. And if I increase the spawn rate now to, let's say, 50, this happens much quicker. And they basically fill up this sphere. Now we have to imagine that we are inside of that sphere. So the island will basically be in the center of the sphere. So we maybe don't want these shapes to appear everywhere inside of that sphere, otherwise they may appear inside of our player. We want them to appear towards the surface of the sphere, but not only on the surface, otherwise it would appear really flat. For that I can make use of the setting called sphere surface distribution in my shape location. This is a value that goes from 0 to 1. If it's set to 0, the cubes or any shapes will appear everywhere inside the sphere. If it's set all the way to 1, everything will appear only on the surface of the sphere, and anything in between will be anything in between. It will blend between these two states, basically. So let's say 0.5 should be good. So we may have some of the cubes more towards the inside of the sphere, but not at the center. Right now, the cubes are all spawned in the same orientation. To change that, we're going to make use of another module. Under particle spawn, I'm going to type in initial mesh orientation. The default mode is set to random, and right now we can already see that all of the cubes have now a random orientation. Still, we only see cubes, even though we have set up a cube, a cone, a cylinder, and a sphere here. To make sure we make use of all of these meshes, we have to dive into the initialize particle module. Here, underneath the mesh attributes, we can set the mesh renderer array visibility to make sure that all of our meshes are shown. I'm going to set this to random, and then I have to make sure that the mesh renderer is set to our mesh renderer. And then all of the meshes are shown here. So now we're making use of all of the meshes we have set up in our mesh renderer, but with this grid texture, it doesn't look very nice. So let's create a material for that. So in my materials folder, I'm going to create a new material. Right click, material. I'm going to call this M color meshes. double click to open it up. And I'm going to set the blend mode to translucent to make sure we can use an alpha, and the shading model to unlit because we don't need any shading on that. Now we only have the emissive color and opacity as input, as well as the world position offset, which we are not going to use. For the emissive color, we're going to make use of the so-called particle color. This allows me to drive the color of my material through my particle system. If I pipe in the RGB into the emissive color, it will show me white, but if I change it in my particle system, it will change in my material as well. For the opacity, I will make use of the alpha from my particle color because I can control and animate this from my particle system. So let's create a multiplier for the alpha, and I'm going to multiply this by a Fresnel to have some sort of holographic effect where we only see the edges of the sphere, for example. Let's set the base reflect fraction into 0, so it is really black, and then I'm going to put this into the opacity. Looks like this. When creating materials for Niagara effects, we have to make sure that our usage flags are set correctly. So if I select my main output node and scroll down in my details panel until I get to usage, I can set up with what this material is going to be used. And here we can see Niagara sprites, Niagara ribbons, and Niagara mesh particles. If I select this, check the checkbox, and then save it, I can then assign it in my Niagara system. So back in my Niagara system, I'm going to select the mesh renderer, and underneath the meshes here, I can enable material overrides with the checkbox. And then override materials, I'm going to add one entry, expand this, and here under explicit matte, I'm going to type in color meshes, set it up, and now we can see that the meshes have changed material. With my material set up, I can now go into the initialize particle setting and set up a color. We can see the initialized particle module is separated into point, sprite, mesh, and ribbon attributes, depending on what type of renderer we use. Per default, particles are defined as points in space with locations, velocity, and all of that. The points have the attributes of lifetime, for example. How long do my particles live once they are born? The sprite attributes are only when you use the sprite renderer. Since we don't use it here, we can ignore it. We have already changed some of the mesh attributes with the mesh renderer array visibility, and we can ignore the ribbon attributes for now. We will use it in the next particle system. In the point attributes, we can also find the color mode, where we can set the color. Right now the color mode is unset and the default color is white. Once I change this from unset to direct set, it allows me to specify a color. Right now the particles are red, for example. I don't want all my particles to have the same color. I want to make use of the color scheme that we have set up in the last tutorial. So I only want to use these 4 colors and randomly assign them to my particles. Right now we only have one input for one color. I could also use random range or random hue saturation value, but this doesn't give me what I need. So I'm going to use direct set again. And here underneath color, I can set up the color so that I don't define it with one value, but with a formula. This I can do if I go to the right here with this little drop-down icon. And here I can define formulas from which my color is then defined. And the first thing I want to do is to multiply my color so that I can assign colors and then multiply this value to make it brighter so that the particles start to glow. So I'm going to select multiply linear color by float. This gives me now a linear color once again and a float value that is meant to multiply this. So if I increase this, we can see these get brighter. Let's reset this back to 1. The linear color I can once again define with this little drop down to select linear color from array. An array, as we know, is a list. We can now define a list of colors, the 4 colors from our color scheme, and then tell our particles to randomly select one of these 4 colors and assign them to themselves. So here under color selection from array, color data, I can add 2 elements so that we have 4, and then I can just set them here from my color picker. First the orange, then the red, then the yellow, and then the green. Underneath array sampling mode, we're going to change this from direct set to random. And now if I start to play, we can see that each particle has one of these colors, but never all the same. One more variation that we can add to make it even more random is to set the float that we use to multiply the final color to a random value as well. So if I drop down here and say random, it gives me a random range float, a minimum and maximum value. Let's set this to 3 and 6. And now randomly these colors are assigned a multiplier between 3 and 6. You can see with these formulas you can create very finite controls without having to create modules from scratch, for example. One more thing to add in the initialize particle module, underneath the mesh attributes mesh scale mode, I'm going to set this to random uniform. Now I'm going to set this from 1 to 4, and all of these meshes now have different scales. If I increase the radius of my sphere shape location, we can see how this looks. Let's make these particles move now. For that, we're going to go to the particle update section. First, I want all of these particles to rotate on their own. For that, I'm going to use an update mesh orientation module. And here I can set up the rotation of the individual mesh particles. So here I can set up the axis on which these particles are going to rotate. Right now they are using the x-axis, and that's fine for me. If I start to play now, all of these particles are rotating, but they are rotating rather fast. And the speed I can change with the rotation rate. One says 1 rotation per second, but I can also drop this down and say random range float and say, let's say 0.2, 2.3. And now they have a random speed and they rotate not as fast. Of course, we don't see really the spheres rotating because they are round, but that's fine. There's another thing I don't quite like yet. Let me set down the spawn rate for this. Let's set it to 2 or 3, and let's start playing. Every time one of these meshes gets spawned, they just pop into existence. I want them to slowly start increasing in opacity, and then once they die, they also should decrease in opacity again, so we don't have this popping effect. For that, I can make use of the scale color module inside of the particle update. Scale color allows me to animate the color of a particle over its lifetime. I can scale the red, green and blue and the alpha separately. And for my alpha, I'm going to use float from curve. This curve goes from 0 to 1, which is the normalized lifetime of a particle. A particle could live for 5 seconds, for 6 seconds, I don't know, but this curve goes always from 0 to 1. And this value is then 1 at the start and 0 at the end, which means it starts at opacity 1 and then slowly fades into oblivion. We have some curve templates here, like these ones, and I'm going to choose the last one, which starts at 0, then increases to 1, and then goes back to 0, all with a smooth interpolation. And this looks much better. Let's increase the spawn rate again to, let's say, 75. We don't see the popping anymore. Now I want to make all of the particles move in space as well and not only rotate. For that, I'm going to make use of the so-called vortex force under particle update. The vortex force is one of the forces that you can assign to your particles. There's also a curl noise force or a wind force, and all of the forces, if you use them, you also need one module after them that's called solve forces and velocity. Without this module, these forces cannot be calculated and will not be applied. It also tells me this with this little red dot here, and in my details panel it gives me the warning, oh, this module has unmet dependencies, and it gives me two options. Add the dependency, so fix the issue, which is very good, or I know what I'm doing, dismiss the issue. I know what I'm doing, but still I'm going to fix the issue. And here it adds me the solve forces and velocity module automatically, and the red dot has disappeared. Now all of these particles are moving through space. In the vortex force, I can also set up on which axis the particles should be moving. So right now it's the z-axis. If I change this to y, we can see it rotates in this way. And if I change this to x, it rotates on the other axis. But I think the z-axis is fine. I can also increase or decrease the vortex force amount, which makes them move faster or slower. So if I increase this to 500, you should be able to see that they move faster. If I decrease this to 50, they move much slower. I think the default value of 200 is fine for now. Let's place our particle system in our level now. So let's search it in the content browser, go back to the level, and then just drag and drop the Niagara system into the level. I'm going to reset its position in the details panel so that it's at the center of the scene. And I can immediately see that the sphere shape, where the particles are spawned, is too small. I could now go back, change it here, and then go back to my level and see if it fits. But this is a perfect case where we could use a user parameter. So let me show you how to set this up. Inside of the shape location sphere, I have this sphere radius value. And to the right of it, we have this dropdown where we can create formulas, for example. But we can also assign a new user parameter, read from new user parameter. If I click on this, it shows me now user sphere radius. And underneath my preview, it gives me a list of all the user parameters. Here we see user sphere radius. If I save this now and go back to my level, I can see this sphere radius under user parameters in my details panel, and I can change it in the level. And this is changed on an instance basis. So every time I add this Niagara system to my level, it will have the default value of 1100 whatever, and I can change it on an instance basis. So every instance of this Niagara system can have a different sphere radius, which is great. So increasing this to, let's say, 3000 should be fine. And then we can see all of these random shapes spinning and filling up the world. The last thing I want to do for this Niagara system is to add another user parameter, which lets me change the mesh size over the duration of its life to be able to animate this in the next video of the series to the music. For that, we're going to go into Particle Update again and add a mesh size, scale mesh size module. And this gives me a scale factor on each of the three axes, X, Y, and Z. I don't want to make the meshes smaller than what they are initially. So I'm going to drop down here and say add vector. And now I have two vectors. Let's set the first one to 1, 1, 1. And now they have the same size again. And now we could add a vector, let's say on X or 1. And now we add to the original size 1 on the X axis. We're going to set this to 1, 1, 1 as well. And then we're going to multiply this vector by a float because I want to scale them proportionally. And this can then go from 0 to 1. So we can increase or decrease the size, but never go below the original size. So let's say multiply vector by float. So we have the 1, 1, 1 vector and one float that will be multiplied with each of the three axes. And this float I'm going to multiply again, multiply float. And the first float I'm going to make into a user parameter. This is the one I'm going to animate. And the second one, I'm going to create a random range float, which allows me to go from a minimum to a maximum. So not all of the particles are scaled the same. So I'm going to say the minimum stays at 0 and the maximum is 0.75. And if I increase the user scale factor, so the other multiply here, it will only increase for some of them. This is the value that I can then animate to the music and make the meshes bounce up and down to the beat. Next, I want to create these magical streaks that float around the island. This is going to be a bit more complex than the last one, but we're gonna get this together. These particles are so-called ribbons, which are basically planes chained together, and we're going to start by creating a material for this. So in my material folder, I'm going to create a new material called m_fx my ribbons, and double click to open it. Once again, I'm going to set the blend mode to translucent and the shading model to unlit. The material is mostly based on this noise texture I've created, and I've provided a link to it in the video description. Let's start by importing this texture into our material. So I'm going to drag and drop it here, and now I have a texture sample. I'm going to duplicate it because we're going to need it 2 times. For the preview, I'm going to choose a plane because we have learned the ribbons are basically planes chained together, and so the plane is the best preview object for us for that. If I add this RGB here to the emissive color, we can see how it looks on the plane. The noise texture is created so that it is tileable. So if I add a texture coordinate and multiply this by, let's say, 2, and add this in the UV input, we can see the noise texture appears smaller, but we don't see any seams. This is how I want to use the texture twice. I want to use it once in a larger scale and once in a smaller scale, so that it looks like we have more detail than there actually is. So let's set this up. I'm going to set the first multiply to 0.5 and then add another multiply, set this to 2, and then connect this to the UV input of the second texture sample. To combine the two, we could use a multiply, and we're going to use only the red channel because it's just a grayscale texture, so one channel is enough. If I multiply this and start previewing this node, it looks like this. We're going to lose a lot of the information because everywhere where it's black on the one texture, it's going to basically negate everything that's on the other texture. I want to use something else, and that's called the max node. If I connect this here and preview it, we see we have much more because it's always going to take the maximum value of both of these textures combined. And that's what we want. Since we're going to use this with a Niagara particle system, we're going to once again make use of the particle color node. So right click, particle color, and let's first of all connect the alpha and the max together with a multiply, and then connect this to the opacity. Let's disconnect everything else and keep clean here, so delete the multiply and start previewing this node. Right now the emissive color is black, so we only see black, but we can see the opacity take effect here. Instead of only piping in the particle color into the emissive color, I also want to multiply this with our textures and then pipe it in here. If we take a look once again at the particle system in the level, we can see with the orange outlines where the ribbons itself move, and also that there's a secondary movement in the texture itself. And that's what we're going to do next. To make our textures move, we're going to make use of the panner node. So right click, panner, and then pipe this in between the UVs. On the top and on the bottom. Feel free to play around with these values. I'm going to just put in the values that I've used in my original example. So 0.3, minus 0.25, minus 0.1, and 0.075. Unfortunately, the preview in the material editor does not always show the animation, only when I move the camera, but we can see the general effect here. With this done, I'm almost finished for now, but I still have rather sharp edges here at the edge of my plane. And that I want to change as well. So I'm going to make use of another texture coordinate, and I'm going to use the sign. Has anyone ever noticed that the sign looks like a very small happy face? I love it. If I start previewing this, set this to 2, I can now see that I have a gradient from top to bottom and left to right that starts at 0, goes to 1, and goes back to 0. Let's saturate this to make sure that our values stay between 0 and 1. And then we're going to break this up and multiply the result back together. Because we don't want this green and red, we only want black and white. And now we have the red and green channels separately, and multiplying them together makes it look like this. We have basically a black and white mask, which is black towards the edges of my plane and white towards the center. I'm going to create a named reroute node for this. Call this mask and multiply this with my opacity. Now the edges are not as noticeable. Let's make sure we clean up after ourselves. So I'm going to create some comments here. Textures. And here, this is my mask. Also, under the usage settings, we'll want to use this with Niagara ribbons. Used with Niagara ribbons. Check the checkbox and save the material. Now we can move on and create our particle system. So back in my FX folder, I'm going to right click, create Niagara system, use the minimal template as well, and click on create. I'm going to call this NS my ribbon and double click to open it up. Here you can see the finished version of this particle system. We're going to make use of two emitters. The first one will be particles with the sprite renderer turned off, so we're not going to see them. But these are the particles that move around our scene. The second one is the ribbons. The ribbons are going to follow these particles and then make a trail behind the particles. We don't see the first particles, but we will see the trails. And that's what makes it easy for us to create these shapes. So let's start by creating the particles that are going to be followed. I'm going to start by adding a spawn rate to the emitter update. Let's set this to, let's say 25. And then under particle spawn, we're going to add a shape location sphere as well. And I'm going to set the radius to 3000 and the sphere surface distribution to around 0.9, something like that. So these points are now spawning towards the surface of this large sphere. Next, in the particle update, I'm going to add a vortex force, similar to the one before. Once again, we need to fix the issue of not having the solve forces and velocity module, so we're going to do that. I'm going to increase the vortex force amount to around 450, and I'm going to add an origin pull amount, which pulls the particles towards the origin, so the center of the sphere, to 200. To make sure these particles do not spin as fast, I'm going to add a so-called drag and set the drag to 0.1, and the rotational drag can stay the same. With all of these particles created inside of this emitter, I need to add the functionality that another emitter inside of the same system can make use of the information that these particles can put out. For that, I first need to tell this emitter that each of these particles is very important, so it needs its own ID. Up top in the properties of this emitter, I can check the checkbox requires persistent IDs. Once I have done this, I can move down to the particle update and add a generate location event. This will now send out events for the location of each of these particles, and another emitter in the system can make use of that. With all of this prepared, I can now create my second emitter. When I right-click in an empty space, I can click on Add Emitter and add another emitter from these templates. Or I can cancel, right-click and add another minimal emitter, for example. So let's do that. Double-clicking here on top lets me rename this. Let's call it ribbons. And once I have two emitters, I can solo them with this little icon of this person, which only shows me this emitter, or it only shows me this emitter, which doesn't do anything, so we don't see anything. Let's first make sure that our emitter uses the correct renderer. So I'm going to delete the sprite renderer and add a so-called ribbon renderer. Inside of this ribbon renderer, I can assign the material that we have created previously. So I'm going to search this in my content drawer, and then I'm going to assign this with this little arrow icon. Let's move on to the initialize particle section. I'm going to select the module, and under lifetime, I'm going to set the lifetime to 3. And I'm going to skip the sprite and mesh attributes and go down to the ribbon attributes and set the ribbon width mode, so how wide the ribbon is, to direct set, and set this to 250. In color mode, I'm going to set the color mode to direct set, and we're going to create another small formula for our color. So once again, I'm going to drop down and say color from curve. In this case, I can create a gradient and say that from this gradient, any color within this gradient should be randomly selected by my particles. The gradient I'm going to once again use, with double clicking here, the colors from our color scheme. Left clicking on top of the gradient adds another color stop. So here's the red. Let's put this towards the center. Then here's the yellow. And we're going to set the last one to green. On the bottom, we have the alpha value. We can see that it goes from color to this grid texture, which shows me that its alpha is 0. So I'm going to double click this lower part here and set the opacity to 1. And now I can see the gradient in its full glory. Underneath, the curve index tells the particles how to select the color from the curve. Right now it's set to the normalized age. The normalized age is the value between 0 and 1 over the whole lifetime of the particle. But since we're setting this when the particle spawns, every particle will have a normalized age of 0. So we're going to change this here by dropping down and just say random range float. And since this curve index goes from 0 to 1, we can just leave the default minimum and maximum values. Now we need a way for this emitter to take the information that we send with the generate location event from our other emitter and do something with that. But we don't have anywhere to put this. So we can add another stage on top here and add a so-called event handler. An event handler, as the name suggests, can handle events. The first module that comes with my new event handler is the event handler properties. Here I can set the source to my minimal location event, so the location event of my minimal emitter here. Then I can change the execution mode from every particle to spawned particles. So every time a particle is spawned. Here I can also set a spawn number, let's set this to 4. And now I can add the receive location event. And with that, we should see the ribbon starting to appear. Let's now disable the sprite renderer from my minimal emitter, save it, and put this in my level to see how it looks. I'm going to center it once again. And let's take a look. When I select the particle system, I can see the outline of the ribbons here in orange. And we can see that the shapes are very straight. I want to have a bit of variation in these shapes, and we're going to switch back to the particle system to add that. First, we have to make sure that we understand what's happening here. We have this minimal emitter, which spawns points in space, puts them on a sphere, and then rotates them around the sphere. The location information is then sent over to my ribbons emitter, which then takes the information and spawns ribbon particles from those points. With the ribbons that I spawn, I can also change their location when they are spawned. So in my particle update, I can also add forces. For example, the curl noise force, which gives some random movement. So I'm going to add the curl noise force. Once again, I need to fix the issue of not having a solve forces and velocity module here. And then I'm going to set the curl noise force strength to 15 and the noise frequency to very low, 1.5. If I save this and go back to my level to take a look at it, we can see that the ribbon shapes are now much more distorted and not as straight anymore. It looks a bit more organic. If we take a look at the original example once again, and I can play the music visualization, we can see what's happening here is that the color is changing from the bottom to the top whenever a note is sung or, in the instrumental version, played by the guitar. Let's implement that into our material. To create the effect, I want to make use of a box mask in the material, which is basically a 3D box shape in space that I can use to mask my material. And the animation will go as follows. The box mask will be very flat, and then it will scale up to its full height, encapsulating all of the particles, and then it will scale down again. We are not going to see this box, it's just going to be inside of our material, basically a virtual box. The box mask is a function that comes with the default Unreal editor. Unfortunately, it does not come with UEFN, but we can find a way around that. Let me show you. I've created a very simple basic project in the Unreal editor, the default Unreal editor. Inside of here, it's very similar to UEFN. I can open up my content drawer, and on the top right side here under settings, I have to make sure that I show the engine content, because the material function is part of the engine content. It comes installed with the engine. Then I see this little engine folder in my content drawer. Inside of here, I can search for box mask. There's the box mask 2D, which is also part of UEFN, and there's the box mask 3D. I can just drag and drop this somewhere in my content, let's say here, copy it here. Don't move it, you don't want to change your engine content. In my content folder, I can now select the asset again and right-click Asset Actions, Migrate. Migrate allows me to move assets from one Unreal project to another. And this works between the default Unreal editor and UEFN as well. So clicking on Migrate, it asks me to save this, that's okay. Now it asks me what I want to migrate. I want to migrate the box mask. And now I just have to find the project folder of my UEFN project. Here my project is called My Oasis 01. In there I find a plugins folder, and once again the name of my project, and a content folder. Always migrate inside of the content folder, not anywhere else but inside of the content folder, and all of the folder structure that you have in your original project will be carried over to your project where you migrate in. Once you click on select folder, then the migration process begins. I'm not going to do it again because I already have it in my project, but just wanted to show you how to get that. With the box mask function now in my project, I can just drag and drop it in my material editor. And there it is. Let's set it up. In the A value, we want the world position. And in the B value, we want where this box in the world will sit. So I'm going to create a vector 3, holding down 3 and left clicking. And I'm going to set this in the center of the world, 0, 0, 0. So this is the center of my box now. And now I have the bounds, once again a vector 3, which allows me to set up how large my box is. And the edge falloff allows me to control how long the falloff goes from value 1 to value 0, where the mask ends basically. So I can have a smooth transition. Both of these values I want to drive by a material parameter, but not a standard material parameter. I want to make use of a material parameter collection. So in my material folder, I'm going to right click, and instead of creating a material, I'm going to go down to the material section here and create a material parameter collection. I'm going to call this MPC my parameters. If I double click to open this up, this shows me a list of scalar parameters, so one-dimensional parameters, and vector parameters, so four-dimensional parameters. These I can add and change how I want. So I'm going to add one, and I'm going to call this beat, and the default value will be 0, for example. This parameter I can then add into multiple different materials, and they will all be driven by one single source. So I could create multiple separate materials, all could be reacting to this beat value, which I could then animate through the music. And this is very powerful. Okay, once I have created this parameter, I'm going to save this, go back into my material, right click, and say collection parameter. I want a collection parameter. Selecting this node in my details panel, I can select the parameter collection which I've created right now, and then under parameter name, I need to select the parameter which I want here. With that, I can now drive these two values, so let's create the nodes for that. I'm going to start by creating another parameter, but a default material parameter, called box bounds. This will be the default size of the box. I'm going to use it as a single parameter, even though the box bounds are 3 dimensions, but the box will be a cube, so the size will be the same for all axes. I'm going to set the default value to 10,000, and then I'm going to multiply this by the beat. So every time the beat is 0, this is also going to be 0. Every time the beat is 1, this will be 10,000. But I only want this for the z-axis. If you remember correctly, the cube will stay the same on the x and y, but it will just scale up. For that, I'm going to use a make float 3, and this allows me to combine x, y, and z into one value, which I can connect to my box bounds. This multiply result I'm going to put into the z-axis, and the box bounds itself I'm going to put directly into x and y, so they don't change, will always stay the same here, but this will change based on the multiply with the beat. For the edge falloff, I'm going to use a lerp. So I'm going to linearly interpolate between two values, connect this to the edge falloff. The default value is going to be 50, and the b value, I'm going to create another parameter, call this box falloff. Let's set this to 500, so 500 centimeters. And the alpha is also going to be driven by the beat. Even though the shape of my box mask is now rather smooth, I want to break it up further with a texture. So I'm going to add a texture sample. And this texture sample is going to use the skydown cloud texture. You can just click on the dropdown and type in cloud. And this is one of the cloud textures that just comes with UEFN. I'm going to animate this texture as well with a panner. Holding down P and left clicking adds a panner. And I'm just going to use the values that I used for my example as well. Add this here. And the result of this just one axis, doesn't matter. Let's take the red one. I'm going to multiply with the box mask. So like this. And this will break up the edges a bit more. And the result, I'm going to add a named reroute node and call this box mask. Let's create a comment for that. Now let's implement this here down the line. I want to change the color using this mask. So first I'm going to get the box mask right here. And I know I'm going to interpolate. So I'm going to use a lerp once again and use the box mask as the alpha. In the A value, so the default where the box mask is not active, I'm going to use the default particle color multiplied with my textures. And the B I'm going to create up here. I want to multiply with another color. I could create a parameter for that. Let's call this beat color. And I'm going to set this to like a violet pink, something like that. I'm going to multiply this, let's say by 2, to just make it a bit brighter and give it more punch. And then I'm going to add this to the original particle color multiplied with the texture. So like this. Let's make a bit of space here. And this add I'm going to put into the B value of my lerp from my box mask. And this lerp I'm going to put into the emissive color. Let's save this. If I go back to my level now and increase the beat parameter from 0 to 1, we can see something happening. It starts at the bottom and then moves up to the top of the sphere. And with that, I've created the visualization for the voice or the solo instrument. Of course, I can also animate parameters from a material parameter collection, and every material that uses one of these parameters will react the same. Alright, let's do a quick recap. In this video, we explored the building blocks of Niagara particle systems. Here they are once again. Systems are containers for your effects and can be placed directly in your levels. Emitters are where particles are generated and controlled, shaping how they look, behave, and evolve. Modules are the core building blocks of emitters, defining particle behavior with pre-built or custom logic. Parameters allow you to control settings within your system, from particle color to lifetime, even from outside the system. We have also created two systems, a random 3D shape system for our moving instruments and a ribbon system for the magical streaks to demonstrate dynamic trails that follow particle motion. With that, you should have the tools to create and customize visual effects for your Fortnite islands. If you have any questions, feel free to leave them in the comments. And if you create something using the techniques we've covered here, please let me know. I would love to see what you do with this. To dive deeper, take a look at the documentation pages linked in the description. As you can see, Niagara is a very flexible and versatile system. You can do so many things with this. The new motion design mode in the Unreal Editor is also powered by Niagara. Here you can use cloners and effectors similar to what you can do in Cinema 4D to create awesome looking motion graphics in real time. Check it out if that's something that might be interesting to you. In the next part of this series, we're going to use the parameters we've prepared to animate the particle systems to the music. But we're also going to talk about character animation and animation in general. If you don't want to miss it, consider subscribing. Alright, that's it. Thanks for watching and see you next time.